Great, fantastic. We're recording. Welcome to the eSig for October. Oh, sorry, November 26th. There you go. Coming up to Thanksgiving and Christmas around the corner. Holidays are almost upon us. Um, yes, welcome to the eSig. Today is the first eSig following WasmCon, so I think the first suggested agenda item is to go through a brief recap of some of those conversations, and then we have some items on our agenda. Some are just reminders, and others are talking points to discuss in a little bit more detail. There is a lot on the list. I don't think we're going to get through it all, but certainly it would be good to get started on some of the most pressing items in there. So, WasmCon, there were fantastic presentations from a number of people on the call today. Christoph Pettit gave a great presentation, as did Dan, on some WebAssembly and WASI related topics, which was great. We had, of course, the panel discussion with Dan, myself, and Stephen as well. That was good to go through that in general. It was more of a general conversation about WebAssembly and WASI and the embedded world. So that was good. My main message for that was love the component model. Think it's a fantastic vision. Just need to make sure we render it in a way we can use it on the embedded devices. Also in attendance for the hallway conversations was ARM. They were there, and I have been trying to gently persuade them to come along to our eSig discussions too. I think that would be quite good. So they were there. Also, there's an overlap between the work we're doing here and the work that's being done to an extent with Margo. So Margo is a consortium of companies looking at how to deploy and orchestrate workloads on the shop floor. And I know Atom and Stephen's involved. I also know Cosmonic is involved in that, as are Microsoft, Schneider Electric, Rockwell, Siemens, and others. I don't think Bosch is on the list, but it's an open consortium. I think it's welcome to go and join, and I can put you in touch with the Siemens colleagues who are doing that. It's not in my wheelhouse, but it's looking at deploying workloads to the shop floor. And in that scope, it's deploying workloads to constrained devices, which then looks at what we're doing here, really, from an embedded systems point of view. So there's an overlap there. So Schneider Electric were at WasmCon, which was good. I think they were just checking out what the constrained devices story and some of the solutions in that space. So that was positive. Then the hallway conversations with Luke, which was also good, about caller supplied buffers and how streaming works. Some really cool stuff coming with asynchronous functions from Joel Dice on Preview 3. But it looks like we would have a async scheduler involved to make this work across language runtimes, which for embedded probably opens questions up about prioritization, the ability to rewrite your async scheduler if you needed to. When you invoke an async function, could you have a priority on that so we can prioritize some network communication over some background housekeeping tasks, for instance? Things like that all come up. Joel's open to the feedback. He's asked for the feedback sooner rather than later, just so that they can think about it. It's good. In that spirit, there's also an ongoing discussion about memory sharing, which kind of kicked off during the hallway track with some of the Renderlet people. And I tried to convert that into something a little bit more solid with an email discussion with the folks I talked to about it. So talked to Christoph Pettit, talked to Luke, talked to Renderlet, and they suggested including Google, and the idea was to bring some of that discussion back into the eSIG. Some of this would go more towards core WebAssembly than WASI. But these are all things that are coming that are going to impact the embedded community, where we have an opportunity to give some feedback before there's an implementation that's rendered, rather than saying afterwards, which I think would be good, right? So, and the key three things for that are shared memory. So four things, I suppose, on that are shared memory, async functions, stack switching, threading. They're the big things that seem to be on the horizon for the eSIG to contribute to. And then there was some general discussions around, we give a presentation on using WASM to C to shrink binary sizes and runtime memory overhead. So we can get rid of the runtime and still compile dynamically loadable code using WASM to C for Zephyr and dynamically load and unload it. And the memory footprint is in terms of tens of to hundreds of bytes. And the wire cost is 1.5 kilobytes on the wire and about 3K in storage on a device. So it's on disk. So it's really, really small. So then that led to a natural discussion about, well, would we actually deploy WASM directly on an embedded device? And for most of our scenarios, we wouldn't. We would probably do AOT compilation, or perhaps, and more unusual devices, maybe a WASM to C compilation. And if we're going to do that, then there's a lot of steps in the pipeline between scheduling and actual deployment of the code to the target. And if we're going to have a pipeline that does stuff like that, then the discussion moved to, ooh, okay, can we separate the developer experience from the deployed experience? So the developer experience could be using maybe Preview 2, Preview 3 components, which we still have some performance concerns about deploying on the target. And could we somehow transform them into something that works with the non-functional requirements that we've got? So unpack a component, maybe. So some brainstorming conversations around that. Nothing committed to it, but certainly the indication from a lot of the conversations I had was it's really interesting. Perhaps there's more to do in the tool chain than in the runtime. So the important thing is keeping, from a developer ecosystem point of view, is keeping the developer story kind of consistent and portable across runtimes and different environments. But the actual rendering of the code that goes to the device, well, that's up to us. And as long as it's functionally equivalent and hits our non-functional requirements, then perhaps there's scope to play in that space a little bit more. And I think I briefly mentioned it to Luke. He said, "Oh, there's some good ideas there, but things you can do and things we've thought about, things you probably couldn't do." And it's great to see Luke here. So that was my takeaway. I'm sure there's others, and I see a hand raised because I've been busy chatting. Thomas.
Yeah, just wanted to highlight that some of the ideas have also been sketched and brainstormed in the SIG-Embedded in the space of Europe and Asia, where I guess also Danua was there, and a few discussions. It's uploaded on YouTube, so if you want to know what has been talked there, just check it out.
Yeah. So I know there's a whole bunch of people on the call who were there at WasmCon along with me. It would be good to get your viewpoints too. I'll open the floor. Christoph, Luke, Stephen, Chris, go for it, Christoph. First hand up.
Yeah, to me there was a lot of interesting things, but the most interesting thing was just talking to Luke about caller provided buffers, and to unify that with the buffers which are used with WASI 0.3. So WASI 0.3 comes with buffers as not a real separate entity, but internally they are used. And if you just make these buffers a real entity, so one which is also shared with a host, you get into a point where with similar overhead, you just really get zero copy. And that is something which I really would like to just bring together with the shared memory. So yeah, so this was my most exciting takeaway from this. So this caller provided buffers. And today I realized, okay, with streams, so WASI 0.3 streams, we should probably get these things added because right now there is a copy in between. And there's probably a way of avoiding that, but this is very recent information.
Awesome.
We would need these caller provided buffers, of course, for that.
Cool. Stephen, Dan, Luke, folks I remember seeing. Any other views?
I think you got all the key stuff, Chris. Thank you.
Just one minor comment, I think, because you mentioned portable across runtimes, and I don't want to be that guy who says portability is not important, but sometimes it's not the most important. You know, like let's be realistic. We're gonna run Whammer, period, full stop. I mean Sony, right? So we wanted to work on that platform, and it'd be nice if it works. I mean, WasmTime, on the other hand, is generally the reference implementation as a superset of everything else as far as features is concerned. So I guess if it works on Whammer, it'll work on WasmTime, I guess, right? But I wouldn't say universal portability is that important for us.
Yeah, I think for Siemens, similar boat. I mean, our chosen runtime at the moment is Whammer because of the performance constraints and the target constraints. But what's also really important for us is a thriving ecosystem. So, yes, Whammer, but it's also really important that that ecosystem is alive, it's thriving, has many participants. There's a choice of implementations if we needed one. There's a standard. All of that becomes as important as it is that we pick this technology. So we've got same boat, Whammer, but let's also make sure that there's a strong, thriving ecosystem around WebAssembly and WASI in general. And that hence the multiple runtime comment. And one of the other, I guess, bits of feedback, I got from the conference was that as you can see in some of the as WASI Preview 2 and Preview 3 evolves, and there's a lot of iterations going on as development happens. The delta from where we are on where other runtimes are and where WASI is getting bigger and bigger. And so the cost of catch up is increasing. So for that thriving ecosystem, it starts to make me think about perhaps this is something we should start talking to the subgroup more generally about, is what steps can the subgroup take to help reduce that cost of adoption? Is that portable implementations? Is it something else that can be done there? But something that would help other runtimes adopt that WASI wherever it gets to. Hopefully it gets to a point where it addresses all of our core concerns too, but whenever it gets there, whatever it looks like, that it's easy to adopt. And that's from more of a keep the ecosystem going point of view. So thanks, Dan. Any other comments? No, we got into that.
One thing I would add to Dan's is I agree, like in our platform, we're largely going to use Whammer as well. And so that's a key part of it. But again, we don't want something that's a fork. And I think when you start looking at the other parts of the ecosystem, the tool chain, the SDKs, the documentation, diagnosis, debugging tools, all that other stuff, there I think we very much want to have compatibility, right? Because then it's one thing if there's a couple different things on WAMR, but we're using standard, WebAssembly tools to build the containers, to build the modules and components and all that other fun stuff. But if there's forks in those things, that gets really messy really fast. And so I think we need to be really cognizant that we don't deviate too much from that, and that it's compatible across that, even if there are some minor differences between runtimes. So I don't disagree with Dan, but I just want to make the point about the rest of the tool chain.
No, it's a really good observation, and especially when, I think the conversation we had at WasmCon kind of went from runtime changes to tool chain changes, and then tool chain stability and conformance and standards for tool chains. And the odd discussion I've had with David from Google and Dan from Fastly about, hey, do you guys need any help on the tool chains? Was yes, nobody really wants to do it. We'd love you to come along and take on some work here. So there is a good chunk of that too. So the other major takeaway, not to sip the corporate Kool-Aid too much, was the mantra, which I know that Bailey and Liam are very keen on, the whole better together thing. And everything that we're doing here, hopefully it's to help the overall ecosystem grow, and that I think's true. So on that very corny note, I think that concludes most of the feedback from WasmCon, unless anybody's got anything else they want to add. Going once, going twice. Okay, right. So announcement wise, current meeting agenda and notes is here. I will post it up on the chat. Now, what we're looking at the moment. So just a heads up, folks. We are in Bytecode Alliance selection season. So Bytecode Alliance Special Interest Group. This is our opportunity to vote for folks who want to stand for the TSC. So they're all up for election, and you can vote if you're a recognized contributor, which I think several of our attendees are. So if you're not a recognized contributor, but you know somebody who is, now's the time to badger them to vote for the right people, for whoever you think should be listed. Just a point to be aware of. Nothing to discuss here other than it's coming up. There's been a few emails about it. The election period is underway for the BCA, so just heads up on that one. So then we move on to issues concerning core WebAssembly. So there was quite a healthy debate in the email, which I think would be worthwhile bringing in here. I'm going to go through this really quickly and then take a very quick straw poll on the top item to focus on, because I don't think we're going to get the chance to do a lot of all the other stuff. And then we can talk about that that way around. So issues concerning core WebAssemblies, 3 key things. Shared memory, it's that discussion I talked about earlier. Happy to bring that in here and give everybody a brief update. I do need to translate that into a GitHub issue at some point so it becomes more open. That's on me to do. So there's shared memory discussion. There is stack switchings coming down the line. And if that's something of interest to us, now would be the opportunity to start giving the stack switching folks some feedback on what it would look like in an embedded system. We haven't talked about that yet, but it's something to do. On threading, I had requests from both Conrad Watt and Andy at Intel for some feedback on how we would use threading and what it would look like. There's still open discussions on that, so now's the time to give them some feedback, and we can coalesce some thoughts on that today if you'd like to. Then there was issues concerning WASI and binding. Exception handling. We're implementing it right now for WAMR, but really, as we stated here, it's not really for for exceptions directly. It's more for the fact that we can map set jump and long jump, which just allows us to execute MicroPython. That becomes a bit more interesting, and use the standard template library in C++ if we needed to. There is discussions on that. So then I think these are the points that I took away from the last European Asia discussion, and I typed them up as like continuing points for discussion from that call. So it was thinking about the fact that most of the embedded space is in C, and then how do you unwrap components and convert them into a module? This I briefly mentioned to Luke, and he had some feedback on that, and I can see him on the call today, so it might be a good opportunity to talk about that. And then, are we doing this the right way? Should we think about, rather than, there was a lot of discussion in the last call about things we can do to get a component to work in a constrained device, and how you might unwrap it and remap it and how that might work. And then the question I had for the wider group was, is this the right way to go about it? Or should we define what we want from our execution formats, and then we know what we're translating into, and it'll tell us exactly what we have to do. It might be another long discussion to work out exactly what that execution format looks like, which could be a different kettle of fish, but it's just a suggestion. So that's where we are at the moment. So core WebAssembly topics, memory sharing stuff. Then there is packaging toolchain topics on WASI, where there was a brainstorming investigatory conversation last time. I'm happy with both discussions. There's a lot to talk about here, and we don't have a lot of time. Anybody have any strong views on what we should talk about or would like to talk about? Or WebAssembly, or the continuing discussion and the wrapping unwrapping? Or you just really enjoy my voice, which would be pretty depressing. So
I'd be more interested in discussing of some of the the interfaces of WebAssembly to the rest of the world. So whether that's WASI and bindings or the wrapping unwrapping, I guess that all falls under it. It seems like the thing we always run into is, you can use your own happy little WebAssembly toolchain to get a WebAssembly module, and then it's all fun and games until you go to interface to everything else. So obviously the issues in core WebAssembly are important, but I feel like you could imagine profiles of WebAssembly that let us avoid those issues for a little longer. But I also don't know if there's a time constraint here, if it's that one or the other is moving faster. So if core WASM is moving faster and wants input like this week, we can do that. In short, I'm voting for interfaces unless there's a time component.
Got it. Interfaces it is. I think Luke's on the call, so that would be a good one to talk about. Any other takers on it?
As mostly a lurker on this call, but I'm especially interested in the comment that the SIG here was mostly C-centric, just because I think that there's a predominant Rust centricity, if that's an actual word, with predominantly in the rest of WebAssembly. I myself have, I'm generally coming at it from a Go-ish point of view. So, I think that's something that is important to talk about when we're discussing interfaces in particular, just because there may be some unpleasant surprises, translating from one to another. Certainly another thing that was discussed, though, a few moments ago, which I think is interesting, which I think Emily was just touching on as well, is sort of the distinction between WebAssembly runtimes and host capabilities that, sometimes we sort of conflate those two of those things, but that's something that's a lot more important, I think, to this group than it is to people who are doing serverless functions or something like that in other parts of WebAssembly. Anyway, I'm going to go back on mute, but thank you.
Before you go back on mute, Ron, I'm taking notes here. Which company are you with? Or entity?
I'm with the Hybrid Group. We're a small boutique consultancy I'm one of the maintainers of TinyGo
Sweet.
and a bunch of other stuff related to WebAssembly on embedded and embedded Linux, computer vision, other stuff of this sort.
Awesome.
Yeah, I'll be quite keen to know a little more about the threading and the input Andy and Conrad requested, because I see the WASI threads pops up. I think it was suspended a while ago, but I see the name comes up again. But perhaps I can connect with Andy directly if no one else is interested in.
WASI threads. This came up at the Plumber Summit. Andy said, and Luke can correct me because it was a comment to Luke's presentation, I believe. Andy said basically WASI threads were being kicked off, but then kind of halted because there wasn't a direct need for it inside the WASI community, or nobody had asked for it. I'm like, we need it. We need threading. We need a standardized interface for threading. So it's definitely something we want. And then he was asking for use cases and examples.
Okay. Yeah. We use WASI threads in production right now, so it is definitely a use case for that.
And there's Luke's hand up. Luke!
Yeah. A lot of people want threads really badly all across the WASM ecosystem. The difference is WASI threads implies a data structure change that makes dynamic linking and multi-threading at the same time really, terrible performance. Like it's if you look at it from a native machine code model, it's very inefficient. Every time you make a new thread, you duplicate the function table. So you get this O(n) times M times N behavior. That's what's effectively wrong with WASI threads, just from a core WASM perspective. And so there's a fix to that in the core WASM CG called shared everything threads. It avoids that problem. It's meant to work correctly with dynamic linking, and it's just going slowly. And the question that came up in the Plumber Summit was, who wants to push this forward now? And everyone just has slightly higher fish to fry and higher order bits at this time. But people are welcome to show up and push forward shared everything threads. That would be a welcome thing to work on. Toolchain work, as Chris said earlier, is a lot of what's hard on these things. The Mscripton team, of course, has a lot of work to do, but they're doing other things prioritized by Google needs. So we need people to work on libc, all WASI SDK, all these different things to help move that forward, and some other stuff too. So it's not for lack of caring. And after this preview 3 stuff, gets out, which is a number of folks higher order bit, then we fully intend to roll right on to the shared everything threads and do it properly.
Perfect. Thank you, Luke. Okay, so that's a brief recap on threading, and we can Marcin, I think Conrad and Andy were looking for just a couple of emails on feedback, and we can kick that off too. Happy to include anybody here who wants an update on that, but just we've been detailing our use cases, which are really a lot of what we need to do is very tight integration with the underlying operating system. But let's take that offline. Let's focus on interfaces. Guys, I wasn't present for the European Asian discussion, but I got a synopsis from Stephen and others at WasmCon about what was happening and tried to transcribe it here in the notes. But perhaps this would be a good one where, Stephen, would you be able to just give a brief recap of some of the concepts and ideas that were floating around from the last call? And then we got Luke on the line, and we can get some of his feedback on it too.
Yes, I can, if I can find my document. It's been a long day. It's been a long day. So I don't have this off the top of my head. In short, though, while I'm looking for this, one of the things that we talked about in that call was, if you look at a runtime such as WAMR, today it does not support the component model, and it does, but it does support core WASM and the ability to run WASM modules. So that, and then back in August, Luke presented the target for WASI Preview 2 dash module, right? Could we take what is in an interface from WIT and then convert that to just a module, effectively unwrapping it from a component? And so those are the two things that really started that conversation. And the idea that we got to was, hey, is there something that we could do during build time or post-processing before deploying it to the WAMR runtime that unwraps a component, allowing us to call those things, right? And so we talked about that idea and the idea of just being able to map that WIT to a standard WebAssembly module and then run it. Of course, the other problem comes is, okay, well, what about all the component model types, right? How do we handle those, right? If I have a string or a structure or a list or some of the other things that get supported, how do we deal with those? And so the conversation that we had in the call was more about like, well, could we do that in container? Could we do it inside of the module, right? Where that we take that code and instead of it being implemented in runtime, it's implemented in the WebAssembly module code as effectively a shim. And those are the two big things that we talked about. I think Dan, I think you were on that call as well, right? Did I miss anything from a high level on that?
I think that's the main point. You know, basically is you put these shims in the tool chain, the SDKs, you know, and they get built in, and the developer doesn't per se need to know about it. I think the main point of this is that to spare the developer the chore of dealing with serialization and deserialization, and put that into the tool chain. Of course, it doesn't support all the use cases that the component model does. It's not like an M to N kind of, you know, type translation. Maybe it's just a, you know, one-to-one. Because the sender, shall we say, right, should be putting it into the format that the receiver can parse it in. I don't know. We can imagine more or less efficient implementations of this stuff. Right. But I think that was the general idea.
Yeah,
Yeah.
and I think the not requiring the runtime to do all that, have all that conversion built into the runtime, because you have a code space issue with things like WAMR.
Right.
There was a third one. I'm sorry. The third one was the ability to do zero copy, which I think is near and dear to Dan's heart. I know Chris mentioned this earlier.
That's what I was about to say. I think this is totally related and compatible with the idea of doing zero copy if we have a model of sharing buffers that is not per se married to the component model itself.
Right.
Right.
And actually, I'll say not more than once copy for Luke, because I know Luke, in our discussion in the wider group you were talking about, there's always a copy once. We just want to avoid a second copy, right? So.
Yeah, I recall that we called it also adapters, not only shims, I guess, and that the responsibility of providing these adapters are not at the runtime, but at the ones who are providing a WebAssembly, call it component, call it call module, call it unwrapped module, and that it gets also loaded when the WebAssembly module gets loaded, kind of in terms of post-processing. And maybe we could imagine that there is some automatic tooling that generates the adapter so that the developer doesn't have to care about it. Maybe using the WIT format description, something like that. Were ideas that have been discussed.
Sorry, I was muted. Christoph, I see a hand raised.
So just from my personal experience, I cannot think of any better solution for combining multiple languages than the component model. And I found that really, if you go for shared everything, there's a lot of optimizations you can do, and it gets very efficient down to really, I was not able to get it any more efficient even by just removing it anymore. And then, yeah, then of course the question of shared buffers, shared memory, these things come into play, and I feel we have an idea, but it's not hashed out enough for just using it already. And it would be post WASI 0.3 for sure. But nevertheless, I feel that there's currently a good way forward. Yeah, I'm working on some proof of concept implementation, and it's yeah, it's really tied to WASI 0.3 and the concept of these buffers.
Luke.
Yes, so I like this idea of a upfront preparatory step that kind of, as you're saying, like unwraps or adapts or wraps, the component into something that can run on a pretty minimal core WASM runtime. That abstractly, that makes sense. What I was wanting to do is ask if how that relates to the earlier point you made, which also makes a lot of sense of we don't actually want the JIT in the runtime. We want to do ahead of time compilation of machine code in a centralized place, because that is actually also, I don't know if you know this, but what we do in Fastly, when the user uploads their module, we compile it once for all the different ISAs and all of our fleets in a centralized location. And then all the edge nodes just pull the machine code. They just pull literally .sos of machine code that are for their particular, ISA, and then they run them. So we don't have actual JIT compilation going on our fleet. It only happens in a control plane. So that's a way in which it's very symmetric to, I think what you're thinking about with embedded, because it just makes a ton of sense, because the JIT adds just a lot of like startup time and like a lot of complexity, and also it's adds security attack surface when you have a JIT in your process. Exactly. So we don't do JIT in Fastly, and so we do that for core WASM. When we upload, like literally that's how everyone does it today. And we're now in the process of rolling out components. We do it the same way. We ahead of time compile the components to the same .sos that get pushed out and run, as just .sos. They've got all the component semantics are just compiled ahead of time into those .sos. So the runtime that runs these component .sos is not fundamentally any more complicated than the core WASM one. There's maybe a few extra tables, handles, but they were somewhere else anyways, and they just kind of moved into WASM time instead of being sitting in the host, because you end up having to have handles somewhere all the time. But it's a really still a pretty minimal runtime. So the question is, do you really want to push to components and compile them to core WASM? Or is it really just compile components all the way to machine code like you would do with core WASM, and then it's really still .sos or whatever native executable format you want that get pushed out to your fleet of embedded devices? And if so, that's something that's very much like that's just ahead of time compilation. That's like business as usual. And we can talk about, for example, just marrying this on the spot to Christoph's idea of the native components, which you presented at WasmCon, which is very exciting. That's a thing that could be a binary artifact that could be portable between runtimes, hypothetically. It would take some work, but you could imagine that the ahead of time compiler could be shared, could be, pulled out of WASM time as an AOT compiler. And we could produce a .so that could run in other runtimes. That is an option. That would take some work, but hypothetically, that's a thing, because you're talking about can we share producer toolchain work. So hypothetically, that's a thing. But yeah. Anyways, those are some ideas.
Like it, Ron.
Yeah, I'm really sorry it was not at WasmCon. I had another obligation on the other side of the world, but something I have been working on a bit in the area of computer vision is using WIT without the full component model, and just compiling and using those interfaces with modules that are WASM unknown, not even WASI, and having some pretty good success with that. So I mean, it definitely works today. There is some thinking about the tool chain part, but it absolutely does work today. If you accept certain limitations, which is you don't have these shared memory buffers and things. The applications I'm working on are primarily looking at it more like the WebAssembly guest modules are like a scripting language, and the runtime is the runtime, and it's the host capabilities where the interesting bits are. So I think that's very compatible with that pattern. I'm not trying to run it on microcontrollers. I'm doing it on embedded Linux, but that pattern is definitely workable with some of the tools we have today. Just to riff on what Luke was saying.
Thanks, Ron. Yeah, that makes sense. I think from our point of view, and the bit that got me really excited about the Plumber Summit is when Luke said we're going to kill the Realec. I was like, yay! So Christoph Petik's presentation at WasmCon, and he goes through what happens in a shared nothing environment where there is a need to mem copy and malloc and free memory in a function call. And for us, doing control loops for timing, and long-running processes in these embedded environments, those mallocs and frees are unfortunately just a red line. It's a square peg in a round hole. We just can't do it. So we'd need some other mechanism for it. And that's where we get back to talking to core WebAssembly about, hey, if we had the concept of some method of sharing memory, both between the hardware and between these components or modules, where it's not all of memory that's being shared, it's a subset, and you can control it and set it up. Oh, yeah, if that primitive was available, and agreed at a core level, I could see how that would ripple through to a WASI P4, 5, whatever comes next, implementation that would allow us to do zero copy communication between the components, and that would be really exciting because it would tick a lot of boxes for us. So that's where I think the longer term view, we're like, oh, that would be exciting. And then that leads to the next topic that I think Dan had brought up. And I'm trying to understand the last call as well. So in the last call, there was, do you have to reformat the data? And I remember, Luke, way back, we were talking about this and you know, the question was, well, if you've got a foreign function interface, but actually you're interfacing between two languages, and the language is the same either side of the boundary, do you need to do the translation? And I think that the conclusion of the conversation was, well, no, but you'd need to know what was on either side of the boundary, and then you could drop it out. Is there any information in the WIT encoding at the moment that would tell you what's on either side of that boundary? So if we did want to unwrap it, could we then go, oh, look, this was a C component and this is a C component, or this was Go and Go, or this was Rust and Rust? Is there anything in there that allows us in that unpacking?
Basically, in other words, if it's a struct that's compiled, it should have this exact same memory layout, right? So you can just go ahead and, yeah.
Yeah. So when it's the same language on both sides, there's really no reason to put them in separate components and separate memories. You can just sort of link them together. The component model allows you to describe how to link multiple core modules together to share memory and share function tables. This is called the shared everything linking. I have a slide that tries to lay this out, how you can use both at the same time in conjunction. So you can, or not a slide, but a document called linking.md, which I'll link here, was specifically to address this. Most people don't realize we have really good support for shared everything linking. But the point is you want to share memory. When you have, even if it's C, in two components with two memories, each C blob of code assumes it has the whole memory. And so they're gonna clobber each other if you try to make them share memory. So the better thing is, instead of putting them separate components and then trying to fuse them, just put them into the same component as two modules that are linked together. So anyways, this document tries to lay it out and show how when you want to share memory, you can do that because it's the same language and they agree on the ABI. And when they're the same, when they agree on the ABI, you have a much richer interaction, right? You can just pass pointers back and forth. You don't have to, you just follow the rules of the language. So that's called shared everything linking. And we can do that inside of a component. You use multiple components when either you want to isolate them because you don't want one traps or out of bounds accesses to impact the other, or when they're separate languages, in which case it's really hard to have them share memory. But if you don't want isolation, you don't want separate languages, just shared everything, link them inside the same components. And maybe there's just one component for the whole application, and that's totally fine. In that case, all you're getting is WIT giving you bindings to the host, and that's fine. That is a fine way to use the component model.
Okay, so I think from my point of view, the way I'm thinking about it is thinking about this developer story. In the future, there's a developer, and I can see the rise of component registries, and I can see an embedded developer going, yeah, I want a HTTP interface. Let's just get that HTTP component and link it in. So at this point, I'm going to have a component coming from the registry, the developer's trying to combine it, and in the developer story now, I've got at least one component that he hasn't, or she, or they haven't written. I've got another component coming in, and I'm going to want to put these two together. And then at that point, I'm like, oh, what optimizations are available for me to get that onto that embedded device and unpackage those components and kind of merge them together. And that's why I was asking, is there anything in there that I can, oh, hey, this was written in Go. Oh, well, I'm going to have to keep the bindings because this doesn't work for my target environment and the rest of it's in a different language. Or this was written in C. Oh, okay, right. Well,
Yeah, I mean that's definitely attractive. People ask that, but there's a ton of devils in the details here. Like for example, if they slightly disagree on the libc version, you try to just fuse them and say, "Hi, you're both using the same malloc." Easy source of crashes, right? And subtle offsets. There's a thousand little things that if you don't agree precisely, and you try to take two components and say, "Okay, now you're sharing the same stuff," it can go wrong. So it would be a really tricky and delicate and probably crashy thing to try to pull off in practice. Hypothetically, maybe, but it's when you're not compiled intentionally to share code from the beginning, and there's like an explicit intention to share memory, it's really hard to just ad hoc throw stuff into the same thing. Like think of why people don't use DLLs in registries. Why don't people have DLLs in registries today? Because it goes badly. They have containers in registries. They've got node packages and they have registries of lots of things, but not DLLs. COM did a thing, right, back in the day, and that went okay. But it was still pretty fraught with peril, and I don't think people were like, oh yeah, that was the answer too. Let's go back to COM. They did ship DLLs, but of course they had the Win32 ABI. They had a lot of things working for them that they were able to just lock down. So I don't know. I understand hypothetically the attraction, but whenever I think through the details, it seems to look like it's going to be a path of pain. We try to go that way, but we do support shared everything language. It's just if you want to share memory, just do it up front and intend to do it. But this ad hoc sharing of memory seems, yeah, delicate.
it's an important thing to bear in mind when trying to imagine what that developer experience is going to be like, right?
Yeah.
And what we can do.
Yeah, if people pull in a thing and all of a sudden just starts crashing, and it's like, okay, these things got fused together, but they actually didn't agree on some like compilation flag that was set when compiling the C code, and now the structs are off by one, and the alignment's slightly different because there's so many things that can go wrong when you try to share struct layout. So if you want to share memory, it's need to be like an intention at build time, basically. Oh, we're all following the same ABI. And what the same ABI is a very subtle. There's so many subtly different C++ ABIs. Everyone doesn't follow the Itanian C++ ABI. Especially with pulling C++, some RTTI, some all the other weird stuff, exceptions. Although maybe we all turn off exceptions. But anyways, so sorry, yeah, it does seem attractive. It is worth thinking about what developer experience and using WITs to try to drive some C ABIs, but I don't know. It seems like, yeah, if we want to both all be C, maybe we just write some C header files and do it the old-fashioned way and just share memory when we want to do that intentionally.
Mm-hmm. Good insights. Thanks, Luke. Cool. Next up. Any
Sorry,
other?
just one quick question on that, and I hope this is not too complicated, but does anybody know how does this work, interop of memory instructs between, for example, C++ and Rust, or C and Rust? Because it somehow seems related.
Yeah, I mean, I guess they do code gen of one from the other, and they
Yeah,
compile with the same LVM with the same compiler settings that make sure all
I
the
see.
structs line up. So they do it
And
up
so
front
that's it.
intentionally.
Yeah.
That's it.
Right.
Yeah.
Right.
And then also, these are both two very, I mean, Rust was very much meant to interoperate with C, C++, so it has that low level lifetime model. So they're all kind of playing the same game in a sense. Yeah.
Good stuff.
Yeah, we've basically using C bindgen. So we just defined the interface in Rust and then used it from C and C++, and found that it's very fraught with difficulties to get the lifetime right, to get ownership right, and all these things. So it's really difficult. And then we used WIT for defining the interface, and everything went so smooth, and all the unsafe code actually vanished into the binding. And it was as efficient as before, especially if you turn on link time optimization. So yeah, I just feel that it's the right way to go. And when it comes to using shared memory, I've seen flat data types, which are representing strings and vectors in shared memory, because they tend to have different addresses in different processes. So you cannot make sure that a pointer really makes sense any longer. And yeah, I just created one of these as well for as a prototype. But later I saw that IceOryx2 already comes with its own flat data types. Boost has its own flat data types. So just both sides have to agree on how to represent them.
Yeah, that we get into quickly get into usage patterns and where it would be used for how we would use the no shared, well, no zero copy memory sharing, how that would work, and what types of data we would expose and how you would access it. And certainly for control loop devices, it is usually lots of code reading hardware values out of memory, doing logic on it and writing out. But we quickly get to the point where we're reading thousands of input variables scattered across memory in no predefined sequence and generating output and thousands of output variables controlling some process. And we're doing it with extremely tiny timing with multiple threads all at the same time, all synchronized across each other. And then synchronized inside WebAssembly and with the native platform upon which it's executing. And then this code quickly becomes complicated enough that it's generally something that's not directly human generated. There's some intermediate stage in there. So I was trying to describe this in the shared memory discussion, but I'll post that up separately and include links in the meeting notes. But in that one, it quickly becomes something that where we would need to have a mechanism of defining where those memory locations are when they're just offsets into something. But I don't know if that would need to be standardized or if it's just like, hey, address 42. That's what you want to look at, right? Offset 42 in this memory region is enough. So I don't know if there's a need for a language specific foreign function interface structure definition for that. But I can certainly see that for C, where we have the majority of the code in the embedded space, it's C, some mechanism to reduce the cost of sharing those data structures. And by cost, I mean development cost. If I have to employ somebody to manually write a WIT definition over a C struct for a large body of code, that's going to be kind of expensive from a maintenance and a ongoing point of view. But if there's tooling or something around that could help, that allows me to bring in my legacy code and expose it in a safe way and reduces the cost of that implementation, that would be great. Dan.
Yeah, to your point, right? Exactly that. You have legacy C or C++, and maybe you want to generate WIT from C++ structs or a C struct, for the sake of facilitating this process, not doing it manually.
Right. And then that would be where, you've got the C structs are usually used across the original open source body and then exposed effectively as part of the package's interface. And rewriting those, it would be a non-trivial thing because you'd affect the entire code base, but you want to just make sure the representation is wittable. That makes sense. Maybe I've invented a new word, wittable. You want a wittable C struct. In some form that we can then expose, that would be kind of good. So yeah, we are 1 minute from time, folks. It's been a good conversation. next steps. I'm going to post up the memory sharing conversation. It was an email thread, but I will put a summary up on a GitHub issue so we can discuss it, and I'll post a link for us all to get in there. A natural extension of that is the Wittable C and what do those in-memory representations look like? And from an ecosystem point of view, how do we support its adoption with the lowest possible cost for existing code? That's the question. So that's it. I will kick that all off. We are at the hour. It is lunchtime here on the East Coast. I'm sure it's in the evening in Europe. Have a fantastic night. Enjoy lunch, folks, and see you guys all in about 2 weeks.
See you guys. See you all.
Thanks, everyone.
Bye, everybody.
Bye.